Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will discuss the general methods for the preparation of alkenes. Alkenes are the unsaturated hydrocarbons that contain one or more carbon double bond carbon. So the general methods for the preparation of alkenes include dehydration of alcohol and the dehydrohalogenation of alkyl halides. So this means that we can prepare alkenes from alcohols as well as the alkyl halides. Let's first discuss the first method, that is the dehydration of alcohols. Now what does the term dehydration mean? Dehydration means the loss of water. Now when the water molecule is released from an alcohol, then it is called as dehydration, and this dehydration results in the formation of an alkene. The process of dehydration of alcohol can proceed through many ways. We may employ different catalysts at different temperature for this dehydration of alcohol. This reaction can proceed in the presence of alumina at 340 to 450 degrees C. This alumina is also called as aluminium oxide, and the molecular formula for alumina is Al2O3. This dehydration of alcohol can also proceed in the presence of phosphorus pentaoxide, and it can also occur in the presence of concentrated sulfuric acid as a catalyst while maintaining the temperature at 140 to 170 degrees C. This is the general reaction starting from the simplest alcohol for the preparation of an alkene. You may see here that we are given ethanol as a substrate here. Ethanol is a reactant in this reaction, and ethylene or ethene is a product in this reaction. In this reaction, the catalyst that is employed is the concentrated sulfuric acid, and the temperature of the reaction is maintained at 180 degrees C. Now, when the dehydration of ethanol takes place, it results in the formation of ethene. We know that in dehydration, water molecule is released. So, in ethanol, if you look at these two carbon atoms, suppose this is carbon 1 and this is carbon 2. At carbon number 1, OH group is attached, and at the carbon number 2, hydrogen atom is attached. Now this hydrogen and OH will combine to form the water molecule, and there would be the formation of double bond between these two carbon atoms, that is carbon 1 and carbon 2. The process for this reaction is that ethanol and the concentrated sulfuric acid is put in a round bottom flask, and then this reaction mixture is heated. After heating, the vapors of water molecules condense back into liquid water, and since ethene is a gas, so it is collected above the surface of water in a test tube. So this is the general mechanism for this reaction, process or procedure for this reaction. Another way for the dehydration of alcohol is by passing the vapors of alcohol over the heated alumina. The process for this reaction is that the mineral wool soaked in ethanol is placed in a test tube. Now this ethanol evaporates at the faster rate. So the vapors of ethanol move over the aluminium oxide. This aluminium oxide is heated. Now when the vapors of ethanol moves over the heated aluminium oxide, then it results in the formation of ethene plus water molecule. Now the water molecules get condensed back into the liquid water, and since ethene is a gas, so it is collected above the surface of the water. This is the structural representation of the alcohols. This structure is representing the structure of ethanol. This is the molecular representation of this methanol. The black dots, black spheres here are representing the carbon atoms. The white spheres are representing the hydrogen atoms. And the red sphere here is representing the oxygen atom. Now, when the ethanol is heated in the presence of concentrated phosphoric acid, it results in the formation of ethene. This is the molecular representation of ethene. How ethene is formed? When this OH and hydrogen atom from the adjacent carbon atoms are removed to form water molecule, then a double bond is formed between these two carbon atoms. This is the double bond here. And this double bond is responsible for, since there is the formation of double bond, so therefore we say that this reaction results in the formation of an alkene. Let's take another example. This is the molecular representation for propanol. This is the molecular representation of butanol. You have 4 carbon atoms. This is the OH group. Now what happens that when dehydration occurs, from one carbon OH is removed, and from the adjacent carbon this hydrogen is removed, and these OH and H combines to form the water molecule. Now between two carbon atoms from which the hydrogen and hydroxide group has been removed, there is the formation of the double bond, hence resulting in the formation of an alkene. So from one butanol we get one butene. This dehydration of alcohol is also called as elimination reaction, because since the two substituents are released from the same molecule, are eliminated from the same molecule, in this reaction which substituent is being removed? H and OH in the form of water. So therefore this reaction is called as an elimination reaction. In the dehydration of alcohol, OH is removed from one carbon atom and hydrogen atom is removed from another carbon atom which is adjacent to that carbon atom. For example, we have propanol here. I will number this carbon as 1 and this carbon as 2. Now if we are removing OH from carbon number 1, then we will remove hydrogen from carbon number 2, not from carbon number 1. We will remove hydrogen from the adjacent carbon atom. Carbon number 2 is the adjacent carbon of the carbon number 1. Carbon number 3 is not the adjacent carbon of carbon number 1. So you have to take care about this, that if you are removing OH group from a carbon atom, then you will remove hydrogen atom from the other carbon atom that is adjacent to this kind of carbon atom. Now in this case, in one propanol, carbon number 2 is adjacent to the carbon number 1. So OH and hydrogen will be removed from carbon 1 and carbon 2 to form water. And then there would be the formation of double bond between carbon 1 and carbon number 2. So this is how an alkene is formed from an alcohol. Now let's discuss another method for the preparation of alkene, and that is the dehydrohalogenation of alkyl halides. What are alkyl halides? We have read about it that alkyl halides are the organic compounds having halogens in them. Those halogens are generally represented by X. What are those halogens? Those halogens may be fluorine, chlorine, bromine, or iodine. So what is dehydrohalogenation? Dehydrohalogenation is the loss of hydrogen halide. This hydrogen halide may be represented like this, HX. Now it may be HCl, it may be HBr, it may be HI. In the dehydrohalogenation, removal of hydrogen and halogen takes place from two adjacent carbon atoms. In the dehydration of alcohols, hydrogen and hydroxide removal takes place from the adjacent carbon atoms. Similarly, in the dehydrohalogenation of alkyl halides, hydrogen and halogens are also removed from the adjacent carbon atoms. They are not removed from the same carbon atom. In the dehydrohalogenation process, the reactants are alkyl halides and the products are alkene. The reagent in this process is the alcoholic potassium hydroxide. There is the solution of potassium hydroxide in alcohol. So therefore it is called as the alcoholic potassium hydroxide. I use the term reagent here. Reagent is any chemical substance that is added in the reaction medium to start that reaction. So when this alcoholic potassium hydroxide is added in the alkyl halide, or alkyl halide is when added in the alcoholic potassium hydroxide, then this reaction starts and results in the formation of an alkene. This is the general equation for the dehydrohalogenation of alkyl halide. Now, this structure in this structure we have mentioned only two bonds, CH and CX. These two bonds are the bonds of our interest. Other two bonds may be H. Just for the sake of simplicity, I am writing H with each carbon atom. Now what happens that this hydrogen and this X group will be removed from carbon number 1 and carbon number 2, and these two groups will then form different products. For example, this H will react with the hydroxide ion of the potassium hydroxide to form water, and this potassium of this base will react with halide to form potassium halide, and then we will get our product of interest, that is an alkene. Let's discuss this reaction by taking the example of ethyl chloride. Now what would happen that when alcoholic potassium hydroxide will be added and the reaction mixture will be heated, then this potassium hydroxide will be converted into potassium plus hydroxide ion. Now this hydroxide ion will attack on this hydrogen atom it will remove the hydrogen atom from the ethyl halide and it would result in the formation of water. Now this bond will be shifted to form a double bond here. Now when the double bond will be formed between carbon 1 and carbon 2, now since the carbon 2 cannot form 5 bonds, so this bond between carbon 2 and X will break and X will be released in the form of halide ion. Now K positive and X negative will react together to form potassium halide and we will get CH2 double bond CH2 in return, that is an ethene. Now if you look at this reaction, then you will observe that X and H are removed from the adjacent carbons, that is carbon 1 and carbon 2. This S, H and X are not removed from the same carbon atom but different carbon atoms that are present near to each other. So only in that case double bond will be formed between the two carbon atoms. Now let's do a self-assessment exercise. We have to complete this reaction. In this reaction we are given 1 propanol and we have to write the end product for this reaction. We are given concentrated sulfuric acid at the temperature 170 degrees C. We know that when alcohol is heated in the presence of concentrated sulfuric acid, then it results in the dehydration. Now for the sake of simplicity, I am writing this structure like this: CH, H, CH2, OH. Now when the dehydration will occur, hydrogen and hydroxide group from the adjacent carbon atom will be removed in the form of water and there would be the introduction of double bond between these two carbon atoms, resulting in the formation of 1 propene. So this substrate, that is 1 propanol, will result in the formation of 1 propene. Now let's discuss the second case. In the second case we are given alkyl halide, that is the propyl bromide here, or 1-bromopropane. You may name it as 1-bromopropane. Now since the alcoholic potassium hydroxide is used here, so therefore this reaction will involve DEHYDROHALOGENATION. Now in this reaction, first KOH will be converted into potassium ion plus hydroxide ion. I am writing the structure for the sake of simplicity like this. Now this hydroxide ion will react with this hydrogen to form water and this potassium will react with this bromine to form KBr. Now from the two carbon atoms from which hydrogen and bromine has been removed, there would be the introduction of double bond between those two carbon atoms, resulting in the formation of 1 propene. So to prepare these topics, you first need to know that how the reaction proceeds, what are the reactants, what are the products, what kind of catalyst did we use, what kind of reagents did we use, what was the temperature of that reaction. And after memorizing these things, you will then apply that knowledge in these forms. You will be given a reactant, you will be given a reagent, and you will have to draw the end product of that reaction. So this was all for today. We will discuss our next topic in our upcoming lecture. Thank you for being with me.